Yes, hello, welcome to a new problem solving in physics. It's Thermodynamics in the book and Engineering Approach Edition 8. Chapter 3, Pure Substances, Problem 335. Yes, we have this, the temperature in a pressure cooker during cooking at sea level is measured to be 250 Fahrenheit. Determine the absolute pressure inside the cooker in PSCR and ATM. Would you modify your answer as place with a higher elevation? Okay, this pressure cooker is literally standing on the water. And we are going to measure the pressure, absolute pressure in the cooker. Yeah, the absolute pressure. The absolute pressure means you will have the pressure inside here in addition to the atmospheric pressure. That is the meaning of absolute pressure. Absolute pressure equals gauge pressure plus ATM pressure. That's we will write the meaning of that and some. There is things I like. I really don't like working with these units. I like the European standards. Well, what we use here in Norway, and then we will translate this to the what is it called? USI units or whatever. I don't really remember what it's called, but the thing is, we will not make this to Celsius. And here, the things that you should know, this is the equation to get it transformed to degrees Celsius. So then we do, the temperature will be 1.8. This is how you translate from Fahrenheit to Celsius degrees. So then I have excuse me. We have to wait 250. Let's just use this equation as I say. So 1.8. Let's call this C plus 32. So you have to get C alone, and then that will be like this. C equals 250 be negative 32, and then you will divide this on 1.8. Then you will find the temperature in Celsius. Use the calculator. And we have 106.89 degrees Celsius. So that is right that, and then we will find the absolute pressure. What we do then is to look at the table, but because I refuse to use the table for Fahrenheit. We have to use interpolation. It's harder, but at the same time, for me, it's more. I just want to work with these units. That's what I like. Let's see here. If we can find, what was this? Was it water? Are you talking about water? No, it's nothing. It's just like a random cooking. It doesn't even say it's boiling. It's just just talking about just pressure. There's no said something is done. Oh man, I go too fast. Let me see. I'll take a break until I find it. Yeah, no, let's just assume it is. It's boiling. You know, that's kind of synonymous with cooking. Right? So, what that means, it's automatic. It's saturated. It's saturated. So let's see. Let's find this here. Let's look at this table. We have how many? What did you find? 100. 100. Let's go down to 110 degrees. Okay, because that's how far we are going. So we have. So let's do this. I had to always need page. Can't everything be one page? I don't need to print out. Is that possible to do in Word to make everything one page? I don't see why not. Yeah, I will learn about that later. So let's see. Okay, 100. We have this. We have this. These two. Right. Let's take these. Not these two. These two. So we will find the pressure here, and then we use the interpolation technique, and then we know the temperature. I have to look again. 106.89. Okay, we will make the. Do I need to make the? Do I need to make the equation, the formula, or you can just basically see the formula as I write the numbers, I guess. So. What did I say? 106.8. My memory is so bad today that I can't even understand it. Okay, 100. Okay, this is what we know. We know this. Minus 105. You know, we have that in that line we are going to find negative the closest minus the closest we have. That's 105. So and then you have the pressure that is unknown. We don't know that. We say P. We call it P. 120.9 equals, and then 110 minus 105, and then 143.38 minus 120.9. There is the formula. That's the equation. We are going to put P alone and then just calculate the numbers with the calculator. And we will have P equals put it in the calculator. Maybe next time I will have a calculator app on the computer, so you can just you're also with me while I'm typing it. Sant. dun. Okay. We have the pressure to be 129.4 kilopascal. That is the number we have. Well, that's for boiling in at 106 degrees. Alright. Well, if there was no pressure cooker, the pressure would be only, then it would be 101.42 kilopascal. But it's have a lid on, a lid with pressure. It increased the pressure to 129.4 kilopascal, and thus the boiling temperature must be bigger. That's how it is. And that's why the cooking will be slightly faster, because the boiling temperature is, instead of 99.96 degrees, it is 106.89 degrees. But anyway, we will find the answer in PSI. We have these things. Let's take this down. Now where we are. Okay. We have this. So the pair, they will be in pair PSCR. It will be 129.4, and then we multiply with that number we see here. 0.1. I don't write them more. That's boring. I will write so 0.38. Yes, I know the next number was not an 8 but a 7, but you round up to the nearest number. Depends on the next number you see. So that's why I write 8, if you wonder. So I will write this. We have an answer 18.768 PSC. That's the answer on that, and then we can also do it in ATM. Then we will I don't like red. I want to have black. I'm not cool. And ATM, and that will be 139.4 kilopascal multiply with. So how many ATMs there is? So 0.00989. Let's say that 100.4 times 0.00989. The answer is 1.277 ATM. and here that is the answer on this problem. Okay, but there is a question. Would you modify your answer if the place were at a higher elevation? Let me think. That's a kind of like a, yeah, so you lift it up. You put this pressure cooker higher up. What will happen? What will happen then? Will be the same pressure because it is a pressure cooker? But I think the pressure in the pressure cooker itself doesn't change. You have to put it on settings. You know, you have to adjust the pressure in the pressure cooker for that to change. So like if you put it, for example, on a mountain, 10,000 meters up in the air, I will change the answer. Yes, then the pressure would be better, I think. Unless the pressure is put in the pressure cooker, it's solid, and it doesn't matter. The elevation. I don't know how that pressure cooker works, but you know, if there is something you know, inside the lid, you know, that is like a it's put on some specific pressure. But anyway, I think the pressure. I would adjust the answer because pressure is pressure. The air is for a fact always a weight on the lid. That will never happen. So I think that the answer would be adjusted. Right. Okay, so that's all for now. See you again next time, and yes.